Hey guys, today we're going to be talking about the difference in energy efficiency between using the elevator or taking the stairs. Alright guys, before we can start crunching numbers, we need to define some basic variables and terms. W will represent work, M will represent mass, T will represent time, D will represent displacement, V will represent velocity, and E will represent energy. We also measure the vertical displacement from the basement to the ground floor and from the basement to the top floor. From the basement to the ground floor was 4.23 meters, and from the basement to the top floor was 7.55 meters. We also measure the time to go up the floors using both the stairs and the elevator. To go up one floor on the elevator was 15.11 seconds, and to go up two floors was 27.21 seconds. The time it took to go up one floor using the stairs at a constant and steady pace was 13.55 seconds, and 24.4 seconds to travel two floors. Our definition is found in the work energy principle. According to this principle, the net work done is equal to the change in kinetic energy. This change in kinetic energy can be found by using an equation defined as the quantity 1/2 m multiplied by v sub f squared minus the quantity 1/2 m multiplied by v sub naught squared. Keep in mind that v sub f is the final velocity and v sub naught is the initial velocity. This whole equation is our definition of work done in both of these cases. Now let's plug in some numbers to this work equation. We will start with the elevator. We know that work equals the quantity of 1/2 m multiplied by v sub f squared minus the quantity of 1/2 m multiplied by v sub naught squared. The initial velocity is 0 because the elevator is not moving at the beginning of the experiment. After some number crunching, we find that the work for the elevator to move up one floor is 123 joules. We can also plug in numbers for the equation involving both floors by using the other displacement and time required, which is 7.55 meters and 27.21 seconds respectively. Mass and initial velocity remains the same in this situation, and after our math, our work value for traveling two floors in the elevator requires 121 joules. Now we will use the same work equation again to solve for how much work is being done to walk up the stairs. Work done to ascend one flight of stairs is 3.78 joules, and our final work done to ascend two flights of stairs is 3.69 joules. Make note that these values are considerably smaller than the values found for the elevator. Let's calculate the energy efficiency for the elevator first. We will start with how much energy is used to go up one floor. The work, 123 joules, divided by the time, 15.1 seconds, gives us an overall value of 8.15 joules per second. And for our experiment for going up two floors, we will use 121 joules divided by 27.21 seconds to get a final value of 4.45 joules per second. Now we can work on calculating the energy efficiency of ascending the stairs. Work divided by time gives us 3.78 joules divided by 13.5 seconds for a single floor. Our final energy efficiency for traversing one floor by stairs is 0.28 joules per second. Using the same equation, but with values found for two floors, we get 3.69 joules divided by 24.4 seconds to find our final value to be 0.151 joules per second for climbing two flights of stairs. So, after finding the different times, amounts of work, and energy efficiency, we can conclude that using the stairs is faster, requires less work, and has a much lower amount of energy used in comparison to the elevator for both one and two floors of travel. This gives a major advantage to the stairs over the elevator. The final question to ask is if you are willing to do the work.